Hi there, you have been using LangChain for a while. You know how to build chains, you know RAG, you know even debug Pydantic validation errors at 2 a.m. We have all been there. But the thing is that chains are dumb. Real world tasks do not do that. Imagine a query comes in, maybe it's a medical billing issue, maybe it resolves itself with general FAQ lookup, maybe it needs escalation. Real world tasks need something that can actually branch loop and think about what to do next. This is what LangGraph gives you. Today we are going to build a full customer support agent from scratch, one that route tickets, looks up order info, escalates when needed, and resolves cleanly. Okay, before jumping towards the code, it would be better if we can have a little coding explanation of why we are going towards the LangGraph instead of LangChain. Okay, so basically, LangChain is a linear workflow, and in it, as you can see, it has only one path. You can add tools, you can add memory, but still you are fundamentally on rails. It is fine for Q&A, for summaries and a small summarization tasks, but not for a you can say workflow that needs to decide what to do next. On the other hand, LangGraph models your you can say workflow in a directed graph. Each node is a function, as you can see, the first node, second node, third node, and so on. And edges define how control flows, uh, and crucially, those edges can be conditional, like uh, from the function 1, it can go whether to function 3 or function 4 or function 2 or all, as the edges are conditional. And this gives you three things that chains never had. The first thing is shared memory, which is called a state. Like the shared memory will be across the whole graph, like the function 1 input, or if you want to store, you can also access at function 7, function 8, or by the end of the graph. The second thing is loops, like the function 1, if routes towards the function 7, then function 7, if it has the edge from function 7 to function 1, it can come back and can loop if there's some, you can say, condition or graph like that. And the third thing is conditional branches. It decide the next step based on what just happened. Think of it like this: LangChain as a conveyor belt, LangGraph is a flowchart with a brain. Okay, so this is how our agent, customer support agent will look like. Where first of all, whenever a query comes in, it will first of all go towards the router node, and the router node will see what is the nature of the query, whether it is a general FAQ lookup, whether it needs some order lookup, or it needs escalation. If it is a general FAQ, it will route towards the FAQ node, otherwise order lookup, otherwise escalate. And as these nodes are for internal, so as we want to also reply towards the user, so for that we have made the resolve node. And what this resolve node do, it will take answer from any of this and then make it human friendly, and then return the you can say response to the user. So this is the general architecture, and now I am gonna build it, and you will see how it turns out. Okay, so let's start with our agent. Okay, so first of all, we will make the main.py that will run our app, and then we will make our shared memory, which is called state.py. And after that, we will make a graph, graph.py, and last we will make all of the nodes, in which the nodes will be the first one will be the router, our router node. The second one will be our, you can say, after router there will be three agents like escalate, lookup order info, and the third one is FAQ agent. Let's make the state typing typed ticked and literal. Okay, so class, and let's call it state will be type tick, Okay, so now there will be the shape for in the shared memory. We will store first of all the ticket. Ticket would be the query that user will provide us, and then the router decision, and it will be literal, and in literal it would be whether FAQ agent query, it will be order lookup query, order agent, and the third one would be our escalate agent. Okay, so they will be our, can say, uh the decisions. Okay, so now, and the last one would be the response that would be returned to user. So this would be our initial, and initially let's make them like this. Okay, now let's complete our nodes. And before completing the nodes, there would be some LLM that would uh, communicate and act as a brain and traverse in the graph. So for that, we will first make the LLM and init client.py. Here we will make the this would be our LLM, right? I am using OpenAI model. You can use any other provider like OpenRouter, IO, AWS. It depends upon you. Okay, so now let's first of all come towards here and make def escalate in dot agent, and in it we will also pass the state. And for here I am using simple print statement. You can use anything else. Basically in this sort of scenario, what happens is you make a ticket in the back end or wherever you want. And also you will do you can say in response, in this the response, for the response we are using it for all of them, and as well as for the resolve agent we can move for the, you can say, for the resolve agent you can make another variable for that, but it's entirely upon you how you want. It is just the general idea of how LangGraph works, so I am going with many dummy scenarios like this. Okay, so now the F for the FAQ lookup. Here first of all, let's get, and then we will use it here. LM is equal to get chat model, and in it we will also make some uh, you can say knowledge base. For knowledge base usually we use the vector database, but here I am making some dummy knowledge base, so entirely up to you. Okay, so this is some dummy document. After this we are also supposed to, from LangChain, okay, so like this we will uh, invoke the LLM and then store it in a variable, and then we will just return as a response this response. Okay, So now let's move towards the resolve node. It will do the resolve agent. This should be our final agent. So let's come back here later. Okay. So first of all, the router node will also have the LLM. We will import it from first LLM, and then we will go client, and in client we will just import the get jet model. Get jet model. As for this router, we need some structured output like this. So we will most probably make a you can say Pydantic model, and then we will use the with structured output. And also from LangChain custom message as well as human message. And we will now make a simple Pydantic schema, and we will then use it. So now we will also add with underscore structured output, and then here router press, and then we will now invoke it by adding system message as well as human message. Okay, so whatever the response is, we will just return it. And as we have now all of them, so just also make the final you can say agent, and in it we will also have for jet model, and then we will also um, okay, so just like this, and then same response, and then we will return it. And as we have now completed all of the nodes and our state is also good, and now we will make the graph. So this would be our start node. Start and end node are basically predefined, and uh, whenever a graph starts, it will start from start and then move towards our whole functions, and then after traversing the whole graph or whatever the desired path is, it would go towards the end. So let's make a function for graph building. Also let's state now we will add here all of the nodes, graph dot add node, and then here all of the edges. We'll first of all import all of the nodes. Okay, so after this, now let's first of all make our first node which would be our router node. So we can say router, and then router agent, same like this, graph dot add node, and then rest of all of. So now let's make the edges, in which the first one would be graph dot add edge from start to router, and then from router whether to go towards FAQ or escalate, it would depends upon uh, what is the output from router. So it would be a conditional edge. Add so we will add a conditional edge, which from router would depends upon where it should go, whether to escalate or FAQ agent or order query. And then from there it would go towards whatever the, let's say for now we need to make the edge from escalate to resolve, order query to resolve, FAQ resolve, because they are all, we are assuming that they are all gonna be rough output in our system, that basically our system will be processing. But for human, we are making a resolver agent that would make it human friendly. So it would be like escalate to resolve, and same like for the rest, and then graph dot add edge from resolve to end, like this, and then we would just return the graph. Okay, so I think that's our code is more mainly complete, and then just make main function, and then get the graph, build graph, and then compile it, or you can say first, if you want to compile it, then you can first compile it and then invoke it. And then just run. Our code is complete, so now let's okay, compile it. Now run this, run just fine. Okay, so if you see that, first of all, what this is our ticket, and then our router identifies it as a FAQ agent query, and it went towards FAQ, and after that this was our final response by our resolver agent. So if I say that, like your service, I want contact your, so let's see. Okay, so it went towards the escalation node, as you can see that from here. So this is the general example of how you build a specialized agent using the LangGraph. It is just a high level overview for, although there are many complex AI agentic architectures that you can build from LangGraph, but this is just the general base. Hope you liked it.